Sharon Metzger with the National Renewable Energy Laboratory. Welcome to today's webinar hosted by the Building America program. We're very fortunate to have Scott Yee, Christine Likas, and Janet McElveen joining us. This outstanding group of panelists will be discussing standardized energy retrofit packages focusing on specific Building America projects that have looked at methods to consistently meet high levels of energy performance in existing homes, and on retrofit packages that can be utilized across many homes. Before we begin, I'll quickly go over some of the webinar features. For audio, you have two options. You may either listen through your computer or over your telephone. If you choose to listen through your computer, please select the mic and speakers option in the audio pane. By doing so, we'll eliminate the possibility of feedback and echo. If you select the telephone option, a box on the right side will display the telephone number and audio pin you should use to dial in. Panelists, we ask that you please mute your audio device while you're not presenting. If you have technical difficulties with the webinar, you can either type a question into the questions pane on your screen, or you can contact the GoToWebinars help desk at 888-259-3826 for assistance. If you'd like to ask a question, you can use, again, the questions pane on, most of the time it's on the right-hand side of your screen. You can type in a question. If you're having trouble viewing the webinar, we actually will be posting the PDFs of the slide decks after the webinar on the website you see there. I'm Sharon Metzger, and I'll be the moderator for today's webinar. I work at the National Renewable Energy Laboratory, and I'm one of the research coordinators for the Building America program. So I just wanted to welcome you guys. I think this is going to be a great webinar and part of a great webinar series, so welcome. The agenda for today is going to start with an overview of Building America that I'll give. And then we have the great presentations from Scott Yee from the PAR team, Christine Likas from BARA, and Janet McElveen from BA PERC. Then we'll wrap up with questions and answers and have some closing remarks. All right, so let's get into a quick overview of Building America, just in case there's anyone out there who needs a refresher or hasn't been introduced to Building America before. So we are essentially a group of 10 industry teams and 4 national laboratories. And we all work together towards the common goal of having the best residential research that we can find in order to reach, high-level goals for energy efficiency and high performance. So we have a lot of different things that we do in this program to try to make sure that we're reaching those high levels of performance. But this is just kind of an overview of some of the different things that we have. So obviously market partnerships is at the center of everything that we do. We are connecting dots basically for the industry to make sure that we're making as much progress as possible in all the different kinds of categories, which I'll get into in a second. We also have different tools that we've developed, such as the Solution Center or Building Energy Optimization tool that you see there. So specifically, what are we researching? We've historically focused on researching how the components of new and existing homes work together. As I stated previously, energy performance, but also durability, quality, affordability, these have always been at the top of our priority list. As we move forward in time, we're really conquering a lot of those technical challenges, and we're adding on those sort of market transformation items like the valuation of energy efficiency and things like that into our portfolio, as you can see in this sort of timeline. we've made a lot of progress. We're actually doing a really great job at achieving these goals that we've had. They're lofty goals, but we have great people working with us, and because of that, we're achieving that high efficiency that we're looking for, along with that high performance. Just to point out a few things that we've done recently that really kind of showcase sort of these amazing things that our program has come out with. Recently, we established a recognition program called Top Innovations. So I just kind of pulled out some of the top innovations that were recognized last year. So under Advanced Technologies and Practices, you'll see things like buried and encapsulated ducts or furnace blower performance improvements. Under House as a System business case, you'll see things like cost-effective, zero-energy ready single-family homes. Under Effective Guidance and Tools, we've worked and succeeded at opportunities in exterior rigid insulation sheathing techniques. And another top innovation that won last year was a window replacement, rehabilitation, and repair guide. And then on the infrastructure side, we've also helped in developing a data sharing standard called HPXML. And those are just some examples, but we really we have like the full gamut of opportunities that we take advantage of in these areas. One of the things that I wanted to gear our attention towards for a moment is the Building America Solutions Center. So this is something that's come online in the last year or so, and it's basically taking all of the great information that we've created with this program over the last almost 20 years and putting it into one easy-to-access place. So this is here for everyone to use and enjoy, and I hope that you'll be able to check that out. All right, so on to today's topic, and just a little bit more about the webinar series. In 2014, this year, this webinar series will actually take the place of the public meeting series that Building America put on previously. So if you were aware of that, then this is sort of a similar representation of the work that Building America will be doing. It's just in a webinar platform instead of in person. By doing it this way, we hope that we can reach more people who wouldn't otherwise be able to attend our meetings. So we're excited about this. And in particular, the topic today is the standardized retrofit packages, what works to meet consistent levels of performance. So this is the first of 10 topics that we'll be having for this webinar series this year. And this is just a really exciting topic to start out with. I mean, this topic, we have 3 different teams from all around the country working with retrofit programs. And it is a challenging arena to work in, as you all in the webinar probably know. But I think that these teams have really tackled it head on and have some great results to share with you today. So now I'm going to introduce the speakers, the stars of the show. So the first speaker is Scott Yee, and he is a program associate at the Midwest Energy Efficiency Alliance. Mia is a partner of the PAR Building America team, and they're working a lot in the area of combustion safety, and they work a lot in that Midwest region, so that's great. Christine Letkes is a senior research architect at New Jersey Institute of Technology's Center for Building Knowledge, and she works with the BARA team, again, really exciting to have her here with us today. And the last presenter is going to be Janet McElveen. And Janet is a senior research analyst at the Florida Solar Energy Center. affordable housing. Since 2009, she and her team have actually worked with over a dozen affordable housing entities, such as local government housing agencies, nonprofit community housing trusts, and Habitat for Humanity affiliates. So all three of them are going to put on a great presentation today, but with that, I'm going to hand it over to Scott Yee.
Hi Sharon, thanks for the nice introduction. Like you said, my name is Scott Yee. I'm from the Midwest Energy Efficiency Alliance. We're a nonprofit based in Chicago that is focused on advancing energy efficiency through programs and policy. We're a member of the Partnership for Advanced Residential Retrofit team, also known as PAR. Our primary goal is to conduct whole house residential energy efficiency retrofit research in cold climates. The research I'm going to be presenting today is from a technical report that's currently in the peer review process. It's a pretty long title. The title is Evaluation of Missed Energy Savings Opportunity Based on Illinois Home Performance Program Field Data, Homeowner Selected Upgrades versus Cost Optimized Solutions. This report is a follow-up on a published technical report that was published last year. It built on the previous study's work to compare measure packages that were actually installed by homeowners with what was recommended by BOP software to maximize cost effectiveness. The research conducted in this report is based on the 5-county Chicagoland region. This geographic area is home to over 3.3 million homes, and many are aging, energy intensive, and very costly for the homeowner to maintain. With this type of housing stock, substantial energy savings potential exists, but the scalability of programs like Illinois Home Performance remains a problem. This study used this problem as an opportunity to determine if a robust set of programmatic retrofit data can be used to evaluate the energy savings potential of standardized retrofit archetypes and measure packages. So essentially we're asking, can large sets of program data be used to develop standardized retrofit packages based on predefined housing groups and archetypes? So just a little more context, the field data drawn on in this study is from the Illinois Home Performance Program, also known as IHP. IHP is Illinois' version of the National Home Performance with Energy Star program. Essentially, it's a statewide platform for existing whole home retrofits in between 1 and 4 unit homes. After completing an IHP qualified retrofit, the homeowner receives a certificate as recognition of completion. The primary goal of this study is to evaluate the energy savings potential of standardized retrofit archetypes in measure packages. In order to evaluate this goal, we pose the following research questions. We aren't going to discuss all the questions and answers in full detail, but our technical report will be published shortly and will include full answers to all these questions. So the first one is, how do modeled optimal energy savings for each housing type compare to the energy savings derived from typically installed measure packages for that housing type? Then, what are the characteristics of retrofits currently occurring under the IHP program platform in Northern Illinois? How do large data sets help explain homeowner decision-making behavior and energy savings objectives? And what housing types should existing programs focus on to provide maximum cost-effective energy savings? So these 4 smaller questions are going to help us answer our large question of, can large sets of program data be used to evaluate or used to develop standardized retrofit packages based on predefined housing groups or archetypes? And this study is going to call housing groups archetypes. These questions were answered by drawing on field data that's been collected as a requirement of the IHP program. The first step in our technical approach was to identify and collect pre- and post-retrofit data from the first 800 homes that participated in the IHP program. Then using MLS data, the homes were assigned to one of 15 previously defined archetypes. These archetypes were developed in a study written by Elevate Energy entitled Chicagoland Single Family Housing Characterization. The individual measure data was then aggregated by the frequency in which the measure occurred and by the housing archetype. After this aggregation, common archetype level measure packages were assigned for each housing group. These common retrofit packages were then used to evaluate energy savings by archetype. An evaluation of energy savings was conducted using two scenarios. One we called IHP common measures, and the second was BOPT cost optimized recommended measures. The baseline used to evaluate and compare these two scenarios is the pre-retrofit energy consumption of each housing archetype. Analysis of these two scenarios has allowed this study to compare the modeled energy savings between what was actually done and what was modeled as cost effective. There are a couple limitations I'd like to point out before I continue into the results. One is that the 2012 IECC code was not included during the modeling of the cost optimal measures. Another is that the cost information draws on the National Residential Energy Efficiency Database. Also, the specific measure recommendations listed in this study are primarily applicable to the Chicagoland area. The primary goal of this research in this webinar today was not to make specific recommendations, but instead to evaluate a method to aggregate retrofit measures by archetype. The tables on this slide show the common retrofit packages for each housing group for Illinois home performance and BOPT recommended cost optimal measures. The most common IHP measures are air sealing, attic insulation, crawl space insulation, and exterior wall insulation. The most common BOPT recommended measures are air sealing, attic insulation, furnace replacement, and water heater replacement. The exact recommendations are not that relevant to this webinar's subject matter. However, the differences between measure packages and methodology used to assess the measure packages are important to this study. The magnitude of difference between IHP common measures and BOPT cost optimal measure packages is significant and varies by housing group. This figure lists the energy savings differences between the 12 housing groups analyzed. Housing groups with values greater than 0 represent homes in which IHP measures resulted in greater reduction in EUI, and housing groups with negative values represent homes in which BOPT measure packages resulted in greater reduction in EUI. 2 out of 12 housing groups experienced equivalent EUI reduction. 4 out of 12 housing groups experienced greater EUI reduction with BOPT. And 6 out of 12 housing groups experienced greater EUI reduction with IHP common measure packages. This figure also denotes which housing groups contain brick and frame construction, and also the relative age of the average home in each housing group. Overall, this analysis has shown that IHP measure packages result in a greater reduction in EUI reduction in frame homes and older homes. This is likely because it's more difficult to insulate the walls in brick homes, and contractors in this region will avoid offering this measure to homeowners. BOPT also does not recommend wall insulation as a cost optimal measure. This is likely due to the high cost of brick wall insulation. IHP measure packages may have a greater impact on older homes because older homes typically use more energy and may have the most to gain from IHP measures that specifically target the home shell. This figure here illustrates the measures recommended by BOPT for housing groups 7, 12, and 14. Due to the overall number of homes in these categories and the energy use patterns, these 3 groups represent the greatest cost-effective savings potential in the Chicagoland area. This figure displays the proportion of IHP retrofit measures in each housing group that included each particular measure. This figure further demonstrates that the homeowner often didn't choose to upgrade their home mechanical equipment. This trend was found throughout all housing groups. At the same time, for these 3 housing groups, IHP and BOPT match closely on building envelope measure recommendations. The exact measure level results are most important to program providers in the same geographic area that these homes were retrofitted. However, the methodology used to aggregate housing archetypes is important to home performance program providers who seek to potentially streamline the retrofit process. One of the primary conclusions of this research is that it is possible to match common retrofit measure packages with predefined housing archetypes. This is important because it reinforces the idea that housing archetypes that share the same construction characteristics will likely require the same retrofit measures. Another important finding is that common IHP retrofit measures can save equivalent or more energy than cost-optimized measure packages. These inclusions are important because they essentially mean that retrofit measures that are applied without an audit to a pre-identified housing group may yield similar or potentially greater energy savings than what has been modeled as cost optimal. Another important conclusion is that aggregation of housing groups can help program providers target specific groups to maximize energy savings for an entire program. We believe that this study has value to existing home retrofit program administrators and planners for several reasons. One is that we found the development of regional housing archetypes is possible using a home's vintage and construction type. Also, installed retrofit measure packages, which are based on home energy audits, are often very similar for each archetype. Thus, with a grading of sample size, it may be possible to remove the audit and assign retrofit measure packages based on housing archetypes. Also, large sets of home performance data can help identify effective patterns and best practices in retrofit measure selection, as well as provide feedback to previous characterization work. And lastly, correlating exact retrofit measure packages based on housing archetypes may help reduce the overall audit and administration time. So the procedure for developing common retrofit packages and matching these packages is market ready, but is still largely dependent on utility program planners. The methodology and framework used to develop housing archetypes is currently available from the DOE Solution Center. The technical report that documents the methods we use to evaluate common IHP retrofit measure packages is currently in the peer review process, and we expect it to be released sometime late this spring. And we found that matching housing group retrofit measure packages with predefined archetypes has the potential to improve the retrofit process for whole home energy efficiency retrofits. Some of the benefits of this is that it could potentially reduce or eliminate the pre-retrofit audit time. It could improve the total volume of individual whole home retrofits. It also could improve the total energy savings associated with whole home retrofit programs such as IHP. And lastly, another benefit is that the measure package standardization may allow participating contractors to develop unique skill sets related to certain building types. Some of the problems with this approach and with removing the pre-retrofit audit is that retrofits may begin to lack customization and measure specificity. Another problem is that this approach has is that it's largely dependent on the development of regional retrofit demographics. This may take a substantial upfront research effort or cost to characterize the housing stock and then eventually assign measure packages based on the housing characterization. And with that, I will conclude with my references and then the next speaker.
Thanks, Scott. Now we're going to pass it over to Christine Likas, and she's from the New Jersey Institute of Technology and the BARA team.
Thank you, Sharon. Just bringing up my slides now. So as Sharon mentioned, I am with the Building America Retrofit Alliance team, and our team looked at the New Jersey Home Performance with Energy Star program to see which packages of measures used in the program will get you 30% savings. So Home Performance with Energy Star is the largest market rate existing home energy efficiency program in the country, and savings in the program range from 10 to 30%. And Building America's goal for existing homes is to reduce source energy by 30%. So what BARA wanted to do is look at whether Building America could formulate a prescriptive package based on the things learned in the Home Performance with Energy Star program to come up with reliable 30% source savings in existing homes. We also wanted to look at what existing conditions would make a home a good candidate for that package, and we wanted to look at how closely the homes that we studied here in New Jersey, how closely their modeled savings met the actual utility savings. So we worked with the New Jersey Clean Energy Program. They're the sponsor of Home Performance with Energy Star in New Jersey. We asked them to call the top 50 projects in the 2011 program year for energy savings. Of those, 42 had modeled savings of at least 25%. We left a few out that had lower savings than 25%. We didn't think it would meet our criteria. And of those 42, we were able to secure utility data for 14 of the homes. To give you a little bit of context, New Jersey is a mixed humid climate. There are 21 counties in New Jersey. The 8 northern counties are in climate zone 5, and the 13 central and southern counties are climate zone 4. We have 3.5 million existing housing units here, and about 38% are multi-unit homes, and the remaining are single-family detached. And we have an older housing stock in New Jersey as well, pretty typical of the Northeast. You can see from this graph that most of our homes are built before 1970. And I raise this issue because here's a study from Florida Solar Energy Center showing the relationship between house age and infiltration rates. So older houses are often leakier. We wanted to bear that in mind with regard to the kinds of measure packages that we were looking at. So among the 42 homes that we analyzed from the Home Performance with Energy Star program here in New Jersey, the modeled savings range from a high of 42% down to 25% with an average of about 29. And again, this is site energy savings that's modeled for the program. And for the New Jersey program, the modeling software that's used is called Real Home Analyzer by Conservation Services Group. And what's nice about that software is it uses utility data from the home. So when you sign up for Home Performance with Energy Star in New Jersey, you have to provide 12 months of utility data, historical data. And that's great because it really, there's been a lot of talk about how energy modeling of existing homes sometimes will over-predict energy consumption in unimproved homes. And since this has the utility data, you don't have that worry. The project costs were funny. They run tenfold, almost $36,000 down to $3,600. But really, you can see that $36,000 figure is a bit of an outlier. In that home in particular, they put in a geothermal heat pump, which had a pretty high first cost. Most of the projects ranged in the $15,000 area. So the measures used in the 42 homes, this graph shows the most common measures. All the homes had air sealing. That is a requirement of the program. So all 42 homes had that. 39 homes had their heating systems replaced. From there, insulating of the attic hatch, either at the attic stair or over the scuttle hole, was done on 32 homes. 31 homes had central air conditioning installed. In some cases, it was replacing lower efficiency central AC, but in most cases, it was installed in homes that didn't have central AC previously. Insulating floor ceiling, that is talking about insulating at the attic floor. And on 30 more homes, water heaters were installed. And then the numbers dropped quite a bit. When we have wall insulation, that was only done on 14 of the 42 homes, and one home had duct insulation installed. When we look at the existing conditions for air sealing, this agrees with the earlier slide, the study from FSEC. These houses are pretty leaky. We have a high of 25 air changes per hour, ACH 50, a low of 6.4, and an average of just under 14 air changes per hour among the 42 homes. Once the air sealing was completed, we had still pretty high numbers here. 20.4 was the top, and down to 4.8 with an average of 10.4 air changes per hour, or ACH 50. And if we look at some guidelines for air sealing, for instance, this is from the Krieger-Dorsey Residential Energy Book, we can see if you look on the left at air changes per hour at 50 pascals, most of our homes are still up in that very leaky older home range. So this seems to imply that we've got, we're leaving some improvement on the table even after the air leakage reduction was done on these homes. For the heating system replacement, the existing conditions, most of the homes had furnaces that were 0.71 AFUE, so older systems were being replaced with new equipment. The 1.90 furnace, that's the same house that had the geothermal heat pump installed. So even though that was not a bad piece of equipment to begin with, they wanted that heat pump. So that's what was happening there. And the others are more typical efficiencies that you might expect folks to replace. The replaced equipment, the most common was a 0.95 AFUE furnace that was done in 24 of the homes, and then there's a smattering of heat pumps and higher efficiency boilers. At the attic hatch, the measure most commonly installed, it was done on 32 homes, but 21 of them had R19 put on the hatch itself, and 11 more had an R14 stair cover installed. And then the next measure on 31 homes, the central air conditioning. As I mentioned earlier, of the 31 homes, 19 of them did not have central air conditioning to begin with, but had it installed as part of the program. And the others had air conditioning ranging from 8 to 10 SEER in efficiency. The new equipment was typically a SEER 16 central air conditioning system, and then they varied from there, but that was the most common in 13 homes. The attic floor insulation was typically 6 inches of insulation added. That was done on 10 homes, and then it goes up and down from there, but that was the most common level of insulation added. Where water heaters were replaced, the most common was a 0.63 EF storage gas-fired water heater. So among the 42 homes, there were actually 16 distinct combinations of measures from the list on the left, and most of them, all but 3 of the 42 homes, had heating and or cooling replaced in the home. But the most common package, package A, on 11 homes looks like this. So air sealing was done, of course, and then the heating and cooling was installed. The attic hatch was insulated and the attic floor was insulated, but the water heater was also replaced. So the average job cost for these homes was $15,460. The modeled savings was 27%. And we only had utility data for 2 homes with this package, but they had an average savings, source energy savings, of 33%. So we know this package works. It's very intensive on new equipment, but it does deliver the kind of savings that Building America is looking for in the 30% range. What was interesting is when we looked at the 3 homes that did not have mechanical equipment replaced, they did not have the heating or cooling, I should say. Now, one of them has not so impressive savings here, the 17%. In this home, I looked at it a little bit more closely. This home was very leaky to begin with. It was the 3rd leakiest home of the bunch, with 24.5 air changes per hour before air sealing was done. And even after air sealing was done, it was still at 17.5. So it's still quite a leaky home, and that may be why the source energy savings was not great. And also, this home has a low efficiency boiler, a 70% efficient boiler. So the equipment is really kind of ready to be replaced. The other 2 homes, though, had equipment that was either 80% or 82%. And they are either above the goal of source energy savings, the one at 32%, or even the 27% is within striking distance. And I like to highlight these projects because we noticed in our analysis that there was a lot of emphasis on heating and cooling equipment. And while that can be appropriate, maybe there could have been a little bit more time spent on the envelope before the equipment was replaced. And then just to pull back quickly and look at the overall picture of the utility data, this is mixing a few different data points, but we have the modeled savings for site energy in the dark blue bar. The actual site energy savings is, and this is for the 17 homes where we have utility data, is the blue and white bar. And in 12 of the homes that exceeded the estimated or modeled number. And then the green bar is the source energy savings. So among these homes, we've still got most of them making or just about making the Building America goal. The last building on the right, again, is the one where we saw that the existing equipment was not too good, and so wasn't able to achieve the goal that we'd like for Building America. So just some air sealing considerations. When we looked at the infiltration numbers a little more closely, it seems that some of the blower door guided air sealing, which is the way it's done here, might be pulling back a little bit too much on more aggressive air sealing, because when we looked at what the building airflow standard is, which is what's used here for making sure that a natural ventilation rate isn't gone below, or you'd have to provide mechanical ventilation. You could still improve these homes by at least another 700 CFM and not hit that limit. So we felt that the potential for reducing loads with air sealing could be exploited a little bit further or be a little bit more aggressive about that. And oftentimes, even if that was surpassed, people are putting in mechanical equipment anyway, so mechanical ventilation might not be the huge concern that it seems to appear to be. But even without that, even without mechanical ventilation, they were well safe of that building airflow standard, and we might want to get a little closer to that to reduce the loads envelope-wise. And the other thing was about wall insulation, since that was only installed in 14 of the 42 homes. Maybe it could be more stressed as a long-lasting practical measure that could be implemented in more of the homes. And so BARA, the package that we are recommending, the prescriptive package, is to go after that 30% source energy savings through the envelope with more aggressive air sealing, getting closer to the building airflow standard, and insulating at the attic hatch and attic knee walls, and at the basement rim joists and basement walls. Most of these homes did have basements, and those two areas weren't touched. So sometimes the envelope measures can be a little bit more messy, a little bit more difficult, but they can provide a great foundation for then if you do go ahead and replace the mechanical equipment. And in locations where it's appropriate to replace the mechanical, of course, adding that to the package and potentially having a downsized equipment. And then where this works, what kind of existing conditions make sense. For the envelope-focused package would be for homes that don't have prior air sealing work, which is quite a few, at least in our neck of the woods, and homes that have suboptimal insulation in the attic or at the basement or foundation. And then for those homes that would have the envelope plus mechanicals, it would be adding the mechanicals when it's at the end, when they're at the end of their useful life, or their low efficiency, like 80% AFUE or lower. And that comes straight from one of the Building America guides, the mechanical guides for contractors to share with homeowners. So that's one of the references that we have here to help gauge whether the mechanical equipment needs to be replaced or not. And this was, of course, an overview, but this report is in peer review and will be available in the coming months, I imagine, on the Building America website. We can look at this information in more detail. And with that, I'll pass it along.
Great. Thanks, Christine. So our next speaker is Janet McElveen, and she's from the Florida Solar Energy Center, which is the lead for the BA PERC team.
Okay, thank you, Sharon. I'm having a little trouble here. Okay, here we go. I'm new to the webinar world. So I'm going to talk a little bit today about our work with affordable housing renovation programs. And even though what I'm going to talk about was done in that sector, we're very interested in expanding our findings outside that to work with other contractors, raters, professional groups, utilities, other stakeholders in the group. And we think that the research that we've done is widely applicable to lots of different types of partners. When Sharon was talking originally about the Building America program, she showed that there was a segment of our research that's focused on house as a system business cases and sort of the house level research. And that's where this work started out. And now we've moved beyond that into the guidance and tools level of research. And I'm going to tell you a little bit about an initiative that we've launched called the Retrofit Challenge. All of this work I'm going to describe was done in Florida, which is in the hot, humid climate zone, and that's the area in orange and red there. I'm sorry, orangish yellow there. So this all got started back in the 2009-10 timeframe when the new construction industry was continuing to decline, and Building America set some goals for existing homes, initially a 15% savings and then a 30% savings. So everyone in the program was starting to think about how can we apply our systems engineering, house as a system approach to existing homes, and can we come up with standardized guidance? When we started looking at how to do this, of course, Building America is very industry focused, so we started looking around for partners. We found that pretty much no one in Florida was doing energy-focused home improvement. We don't really have a home performance industry here. The utility programs are not whole house focused. We don't have home performance with Energy Star, so we were a little bit at a loss. However, we got lucky and a partner came to us. Sarasota County had some funding from HUD to purchase and renovate foreclosed homes and sell them in the affordable housing sector. And the first thing they asked us for was the list. Tell us what to do and we'll do it. But we didn't really have the list. The first thing we told them was hire a home energy rater, to which the response, which was very common in our field study, that their program guidelines did not allow them. It was not an allowable administrative cost. So luckily we got to work with them a little bit. So this is the standard procedure for this field work. The scope of work for each house was developed prior to purchase so that the economics of the money spent on the house and the potential sale price could all be worked out. Then in number 2, we got to visit the house and do a pre-retrofit audit and analysis and develop recommendations for reaching a 30% improvement based on what the partner was already going to do. Then we handed that off to the partner, and they considered those recommendations, and it included things like projected annual energy cost savings, and they made decisions about what the final scope of work was going to be, factoring in lots of other priorities, like availability from their usual contractors, market expectations, and so forth. And as such, we feel like the packages that they selected and the best practices that ultimately came out of them are a very strong reflection of actual market, what can be done in actual market conditions. We also provided them with first-year cash flow analysis, which is basically how much we're going to save in the first year versus how much it's going to cost to finance any improvements, the mortgage cost. And that is a metric that we use in Building America regularly to assess cost effectiveness. Well, we started out with Sarasota County, which is that cluster of yellow dots on the west Gulf Coast. But we quickly found out that there were lots of other local government entities that had this kind of funding that were interested in what we were doing. And we ended up with 70 houses kind of sprinkled along the Central Florida East Coast and the West Coast. After the 70-house field study, we took the best practices that we found in the field study and did a pilot implementation study. And then out of that came this Retrofit Challenge initiative, which is what we're hoping to invite some of you to participate in. These are the types of houses that were involved in the study. You can see we don't have any houses in our study from the 30s or the 40s. Most of the houses were built in the 60s, 70s, and 80s. And what we're seeing here in the text on each picture is a HERS index associated with a certain decade. And the HERS index, for those of you who don't know, is kind of like an MPG for your house, except it's like the golf score. The lower the number, the better. And what we were looking for was a 30% improvement in HERS index. whereas the other two presenters and others in the industry are focusing on annual energy use reduction. The partners that we had were familiar with the HERS index. They've used it in other programs for new construction, and it also normalizes, so they could compare the improvement they made in the 800 square foot house to the amount of improvement they made in the 1,200 square foot house, where the annual energy cost would differ greatly. So each bar on this graph represents a single house in the study, and the y-axis is showing the percentage of improvement. So the minimum improvement was 6% up to a maximum of 60%, and 46 of the renovations met our 30% HERS index improvement. So the obvious next question was, how did they do it? Well, in our mind, turned exactly to the same place of looking for archetypes and hoping that we could develop something for age-related package. And you see here, we're showing in these paired bars the average pre-retrofit HERS index with the blue bars and the average post-retrofit HERS index in the green bars for each of the decades. And you can clearly see a trend downward, which is better on the HERS index. And we're going to look more specifically at a single decade in just a minute. But what we weren't prepared for, what we didn't expect, is a similarity in the post-retrofit HERS index, that by applying sort of a similar approach across these houses, they had sort of ended up at a similar level of efficiency. So in our quest to look for a standard improvement path, we began to slice and dice our 70 houses of data. And this is the same pair of bars for each house in the 1960s. And what I want you to notice here is that the blue bars, the pre-retrofit HERS index, is just all over the place. Even though these houses were built in a similar time frame, and some of them even in the same neighborhood. What the difference is the way the house has been maintained over the year. Did the air conditioner get replaced 2 years ago, or was it 15 years ago? So that diversity in starting point is very challenging when you're trying to achieve a particular level of improvement. The starting point is a really big factor in how much you can improve. So what we ended up with was not a one-size-fits-all package for 30%, but what the stakeholders were really asking for, which was a similar treatment that produced similar end results. And I'm going to say a little bit more about that. Again, notice that the green bars are at a relatively similar level on the HERS index, and that red line indicates what a typical new Florida home built to the Florida Energy Code would score on the HERS index. It's not a one-to-one scoring, but this is typical. And you'll notice that most of the green bars are falling right at that level or better. So we're doing good. We're getting houses up to the same level of efficiency that buyers would expect out of a new home. So since the approach of looking for a standardized package within the decades didn't work out for us, we started looking at the data in lots and lots of different ways. And we ultimately determined that most of the 46 deep retrofits had improvements that fell in 4 categories. Low cost, no cost measures that you could do on pretty much every house. Health, safety, and durability measures, which are the foundation of high-performance housing and Building America's systems engineering approach. And then the third category was moderately higher performance replacements, not super high efficiency. We're just showing here SEER 15 heat pump. But if your house needs more of these replacements, the HERS index is going to be higher, and when you replace them, you're going to have a greater level of savings. The fourth category was efficiency enhancements that didn't have anything to do with replacements, like sealing the duct system and adding insulation. These are very similar to the things that we saw in the previous 2 presentations. Delving down a little bit farther into the how, we looked at the 46 deep retrofits, which we're showing there in the green rectangle, and determined that they had in common some specific strategies, these 13 key strategies. These are in order of prevalence. So all of the deep retrofits had, 96% of the deep retrofits on line 1 there had an HVAC replacement. Not all of them, so you could still get to 30% without replacing the mechanical system with a different combination of these efficiency measures. the really interesting thing to notice here is that the houses that didn't achieve the 30%, which I've got the red rectangle around, had a lot of the same efficiency strategies in them. Most of them just didn't have as many. So again, this idea of combining more improvements obviously drives the savings percent higher. So this is a pretty typical package of improvements. If you fully implement the best practices that came out of this study, you're going to get more than 30% savings. But you'll see here there isn't any rocket science. There's Energy Star products, the heat pump, R38 ceiling insulation, only moderately tight whole house ceilings and duct air tightness, Energy Star windows and refrigerator. Moderately more efficient electric water heating. We had very few gas houses in our homes. And then we have lighting, controls, and some exterior treatments there. So it's nothing you wouldn't expect to see in a new construction house. But what did it cost? Everyone wants to know what it cost. We had costs for 42 of the deep retrofits, and each one of these dots is one of those houses, and on the x-axis you see the percent of savings for that house, and then on the y-axis the dollar amount that was associated with that. And this is incremental cost. So we see that most of the houses fall within about $2,500 to about $5,000 range. And these were in houses where tens of thousands of dollars were being spent on a comprehensive renovation, so a very small percent increase. So we took all of this information from 70 houses, and actually there were more that didn't make it into our full data set, and boiled them down into some best practices. And that's the publication you see on the left. It has, the organization is by component, so you can see in the middle of the table of contents is showing you heating and cooling, whole house air tightness, roof finish, and for each one of these, we show a treatment. We make recommendations for if you're going to replace that component, if you're not going to replace that component, and then items for all houses. And I have a close-up of that so you can see a little bit more specifically the kinds of things that we're talking about. So whereas the previous, the 13 key strategies are more general, we're really getting down into the nuts and bolts here. Under the full or partial system replacement, not only do we have a specification, but then we also have items about sizing, dealing with accessible ductwork, the design of the air handler closet, and so on. And these are things that speak to the systems engineering process and how to really take the home performance criteria down to a level of metrics and specifications that can be verified by program managers. So we took our best practices and we started looking for new partners to adopt them and implement them so we could refine them. And the City of Fort Myers and the City of Melbourne did that. They added our best practices to their standard rehabilitation guidelines. And our sort of goal moving forward is to repeat that process with more partners in the hot, humid region. We've relaunched this initiative in challenging affordable housing agencies and other stakeholders in the existing homes industry to step up and aim for high savings and high performance. This landing page, the Retrofit Challenge, has all of our reports and a checklist that's a little bit, it's a 3-page checklist for the best practices. And this item on the right is how you initiate participation in this. It's just a pledge saying that you have decision makers on board, you're seriously considering participating. One of the resources on that page are case studies that we've done with partners on specific houses, and these show you the kinds of packages that were implemented, how much they cost, associated details. Some of them are more detailed than others. But if you are not in our climate zone, you can access this kind of information from the Building America Solutions Center, where you can find case studies, and you can also filter by climate zone. If you Google Building America Solutions Center, it will take you right there. So quickly, the recommended guidance I have for programs, affordable housing programs that are wanting to move in this direction is to define your replacement triggers, like what the conditions are going to be if you're going to do a mechanical system replacement. And then have very specific specifications so that you don't have to evaluate that on every single house. So any house that needs attic insulation, you've got a specification that you're going to strive for there. But in addition to just the numbers and the specifications, you need to define some standard detailing to address things that are commonly appearing in your retrofit homes. In Florida, return air plenums, return systems are central rather than fully ducted, and using the bottom of an air handler closet is a very common detail. So we came up with a standard way of resolving that was adopted by the City of Melbourne and was very successful. The next point of recommended guidance is, as you draft your master specifications, you need to be talking to all of the stakeholders and decision makers that are needed to ensure successful implementation. This is a big piece of the Building America approach, is bringing all of the important perspectives to the table. The last thing you want is to come up with master specifications, start implementing them, and then have the code inspector tell you it's against fire code. Those are the conversations you need to have in advance. Then you'll notice this guy down here in the right-hand corner. Most of the partnerships that we formed, there's been someone very enthusiastic about it. It kind of spearheads the program and does the research and encourages everybody to start moving in the same direction. That's the person you want to find. The next piece of recommended action is, once you have developed a standard sort of approach, don't let that be a static document. Take that language and translate it into, or incorporate it into your bid documents, however you're producing your work write-ups and scopes of work. And most of our partners were using software that they could write standard language in the library so that every single time they were going to be doing, say, window replacement, they were using the same language. Your contractors that they were working with knew what to expect, and it was a smoother process. This is a close-up of one of their work write-ups, and this is the next piece of recommended guidance, to develop some feedback loops so that program managers have ways of ensuring that the specifications and performance criteria are met. It's one thing to write down that you're going to have 6% duct leakage or less, but developing something like this, which is have a duct leakage test done and a passing report sent to the housing department, allows there to be a record keeping and a quality control that's really important if you really want to see those standards upheld in the field. So at this point, we're able to go back to those stakeholders, other housing programs that want to do something like this, and we have material for them. So we feel like we've kind of conquered that. And speaking of potential partners, this is the lay of the land we see as potential adopters of this approach, these best practices. In Florida, there is funding from HUD for renovations and community redevelopment that goes straight to the state and that filters down to the local level. And from local government, you can see over in the secondary recipients line that the local government usually contracts with nonprofits or for-profit contractors to get the actual work done. So this is a tremendous pool of people that by doing something like this, we can expose to building science and systems engineering process and hopefully facilitate and catalyze change in how retrofit work is done. Even if a partner isn't ready to commit to very high savings level, just having that exposure to staff and other stakeholders in the area can raise the potential for deep energy retrofits in the future. The last slide I have here is, we know that this is not a substitute for individual evaluation, and that's one of the best practices, is to hire somebody to look at individual houses. But when that is not a possibility, this can substitute as a standardized method. Because it's general, though, it might miss unique opportunities in a house. And we know that we haven't addressed every condition that's going to arise in the field. For example, This study included primarily slab-on-grade houses. That's primarily what we have in Florida. So we don't have a great deal of guidance on frame floors. So we need to incorporate that from other resources. The pros, though, are that it establishes a consistent treatment across a widely varying housing stock. And we saw that in the couple of slides where we were seeing that the end point, the post-retrofit level of whole house efficiency was similar, even when pre-retrofit efficiency was very diverse. We're looking at very low-risk, late adopter technologies here that are proven and readily available in the marketplace. And as I said before, even if our partners or the audiences for this information aren't ready to do deep energy retrofits, we're raising awareness of heat, air, and moisture flow dynamics, which are critical for deep retrofits. And we're drawing attention to potential risks and ways of dealing with them. I think that's my last slide, Sharon. So okay, I'll turn it back over to you.
Thanks, Janet, and thanks to Scott and Christine. Those were all great presentations, so appreciate you putting those together for us. We've definitely been getting some questions rolling in throughout the presentations, so I think we'll start with Janet, I guess, since we have your presentation fresh in our mind, we can work backwards. So one of the questions that came in was, did you consider solar hot water, duct encapsulation, and ductless heat pumps in your study? And if not, why not? I don't know if you can address that at all.
Repeat the four technologies: solar
hot water, duct encapsulation for ducts that are in attics, and ductless heat pumps for the heating system or the cooling system.
Yes, and those are all technologies that we personally are looking at a couple of those, and I know Building America in general is investigating duct encapsulation, and right now that's an area that is receiving a lot of attention because of some new findings there. In the best practices, we recommend that programs evaluate not only solar water heating, but heat pump water heaters and tankless gas. Those three options did not turn up in our field study. We recommended them, we discussed them with partners, but under the market conditions and the funding conditions, we didn't have any houses that incorporated any of those three improvements. We did have a heat pump water heater, which is a higher performance water heating system. But because the best practices were driven primarily by what the partners actually did in the existing market, some of the higher performance options that we see in new construction Building America homes were not there.
Okay, thank you. Another question that came in was related to just a question of if you ran into any 50s Cape-style homes with knee walls on the second floor, and if so, what did you do with those knee walls?
Is that for us or for general?
For Janet.
Okay, for Janet.
I guess
yes.
It could really be for all of you, but.
Speaking for our study in Florida, we had very few two-story homes at all. We do have a specification in the best practices for knee walls because what we have sometimes are vaulted ceilings and differing ceiling heights. We use the same specification that we use in new construction home, which is R13 insulation. It's very difficult to get much higher than that because of the depth of the framing members there. But we didn't have very many houses in our study that had those kinds of ceilings.
Okay, great. We have one more question related to whether or not the Windows upgrades that you saw were cost effective.
Yes, that was a really interesting dynamic. We always showed when we did our analysis at the house level the first year cash flow for all the individual measures, and consistently partners were telling us they were going to put in Energy Star windows, so it wasn't even something that came up for us. However, never was it actually cost effective in terms of the amount of energy you were going to save for the relative cost. And we told them that. We told all of them that. I mean, and certainly we weren't making those decisions, but almost in every single case, they decided to go forward with the Energy Star windows. And the feedback was that since it's an envelope measure, it's probably not going to come up again for 10 to 20 years. So they opted to choose those windows over something that might have been cost effective, a single pane tinted or a double pane tinted, because of concerns for long-term operating costs. And that, because this was an affordable housing study, those kinds of decisions are more affected by long-term performance than sometimes in market rate housing.
Okay, great. We actually have a couple more that just came in as well for you, Janet. So in Florida, there's a question presumably from a local Floridian. How do we get HUD and DEO to encourage the move to promote some of these best practices? They've asked on numerous occasions, and the state leadership defers to local initiatives. So I guess maybe just talk more about how you got those partnerships to work with you.
Well, and I think that really is how it works, that from what I can tell. And this was the first time I had really worked with recipients of HUD funding. We've done a lot of work with nonprofit housing groups, Habitat for Humanity. But it seems to me like, from what we saw, a lot of the decision making is done at the local level about how the funds are actually going to be executed and what the priorities were. However, every single partner that we talked to, even those who didn't end up in the field study, they wanted to do energy efficiency, but there's just an awful lot of confusion in the marketplace about which things really work, especially since Florida has a little bit different climate than some of the other climate zones. The marketing material from different manufacturers may be slanted toward other climates. So I think it really takes that enthusiastic person that I mentioned in an earlier slide to get on the bandwagon, so to speak, and develop some local standards. If we could have done this at the state level, we would have. We would have taken this to some central resource at the state level, but we couldn't find one. So that was when, once we'd worked with a couple of local governments, we thought ourselves the same thing: how can we get this to be incorporated on a larger scale? And I will say that the HUD program, two of the HUD programs, Neighborhood Stabilization and the SHOP grant programs, are both now requiring an energy efficiency component. SHOP grant is for new housing, and they require those houses to be Energy Star certified. And the NSP program in the second and third rounds had specific energy efficiency criteria that had to be met. So there is some movement in that world, I have to say. The Florida Energy Code, too, is pretty good as state codes, state standards go. The Florida Energy Code is doing a good job, and I think that mechanism is working in Florida.
Great. Okay. And I think this will be the last question for you, and then we'll move backwards towards Christine. Just one more question about if another technology was considered external shading for south-facing windows.
Yes.
Was that considered?
I'm a big proponent of exterior shading. We didn't have any, and in fact, I guess that was a little bit of we didn't include that in our analysis. Most of the time, we were given the scope of work that included a window replacement, and if it didn't include a window replacement, then we included window film as one of our modeled improvements. Exterior shading is a little bit of I won't say it's risky, but there are aspects of it in Florida because it does represent a wind load situation. I think builders in general are less confident about installing exterior shading. I think it's really, if you're a homeowner and you can do it directly and you know you're going to have control over what happens to that when there's a Class 3 hurricane coming, I think it's a great, and you're going to get similar results to doing window film.
Okay, great. Thank you, Janet. Okay, so now we have a few questions for Christine. There was a question about the Real Home Analyzer. If you could, I don't know if there's a link to that or a reference that you could provide. I know you had talked about previously that it was a proprietary software tool.
Yes, it is proprietary from Conservation Services Group, and I believe that it's only available to participants in Home Performance with Energy Star. At least that's the case here in New Jersey. I was actually only able to get the user's guide, and frankly, I Googled to get that. But maybe CSG, Conservation Services Group, might be the place to look for more on that. I do not have the software.
Okay, and then I guess just so that everyone on the call is aware, our program has developed a free software called Building Energy Optimization that you can get that would, I don't know, it wouldn't provide exactly the same capabilities as that tool, but it's fairly similar, and you can still model pre and post energy savings in an existing home. And the website for that is beopt.nrel.gov, and it's beopt.nrel.gov. So that might be able to help a little bit. And another question was, in the New Jersey project, did you include measured savings or just modeled only?
Well, for the 17 homes that we had utility bill data for, that was the actual savings, and that was really important to us to get that utility information. People were it was hard to get, so we got from less than half of the participants, but then we did calculate the source energy savings based on the utility data. But even from the utility data, we had the savings were solid, except for 3 of the projects. They were all making that 30% or more savings.
Okay. And another question came in for you specifically on if you had any, if you ran into anything in particular with those second-story knee walls in Cape-style homes.
Usually what is required here is that, that the fibrous insulation is put in. It depends on what kind of space is available, R13 or R19, and then they like to have an air barrier. So if it's the kind of crawl space knee wall where you can get behind into that little eave area, they like to see the fibrous insulation and then either rigid insulation or some sort of sheet good put on the back side of the stud bays if those are exposed.
Okay. And then there was a question here about unvented attics. So I don't know if you ran into that at all, if that may be more a question for Janet as far as the retrofit goes, but kind of spray foaming the roof deck to create an unvented attic so that the decks are in conditioned space. I don't know if you ran into that at all.
Not in the homes that were in the 42 homes that were in this grouping. I did not have that.
Okay.
Sharon, we didn't have in the Florida study, we didn't have any homes in that particular study. We have done a couple of retrofits under other funding that went to an unvented attic, but by and large our projects were not gut rehab, and doing an unvented attic in the types of houses we were working in is challenging unless you're pulling down the ceiling drywall, because they're very low sloped roofs. We're talking about 2 and 12, so it's a bit technically challenging.
Definitely. Okay. Another question for all of you. Let's see. Sorry, just trying to find my place in these questions. This one was about payback in general, and if you guys had looked at that at all, what were the payback times for the homeowners on average, I guess you could say, for some of the homeowners? Was that looked at, or do you have any note of that at all?
Yes, this is in the Florida study. We looked at first-year cash flow, and that was we did that for every individual measure, and we did that for the packages. And we didn't recommend any improvement that didn't produce positive first-year cash flow. I do have those numbers in our major report. I don't have it at the ready, but I think there were only 2 or 3 projects that did not produce a positive first-year cash flow for their whole package. One of them didn't because they did what they do, an instantaneous electric water heater, and it was very expensive and didn't produce much improvement. So by and large, it was all positive first-year cash flow, and that is in our technical report, the first technical report that we did, which is available on baperc.org/retrofit. What about you guys?
The Illinois program, the payback is typically between 5 and 13 years.
And for New Jersey, the projects that you saw, I didn't have the breakdown of the financial arrangements for each of the projects, but most of them, just anecdotally from the program contractors, take advantage of a loan. What they do is the New Jersey program offers an interest-free 10-year loan, which is pretty nice for folks that implement measures and meet at least a 20%, I believe it's a 20% savings. And then the way that a lot of times the measures are figured out is that they figure out how much that loan payment will be and try to match it to the savings, so that if you're saving $70 a month on your energy bill, that's your loan payment for the amount that's spent on the measure. So that's typically how it's calculated.
Okay, great. So Scott, I have a question for you next. So having read, this is coming from one of the listeners, having read the Chicagoland housing characterization, they know that the housing groups often involved brick homes that are, if they're pre-1978, they're assumed to be a double brick exterior wall. So the question is, did you run into that at all? And if so, how did you achieve a retrofit in that case? Or a suggested retrofit?
Yeah, we didn't look at that construction type specifically. I think that person's probably referring to some of the bungalow homes. I do know that I don't know the exact method, but they were able to spray some insulation in between the two. Chicago has the Chicago Historic Bungalow Association, and they sort of work on technology and techniques to insulate those types of buildings.
Okay, great. And another question for you is, how would a utility program manager use this information that you found? And maybe this is one that all of you might run into.
Yeah, I think this could help a utility program manager, because if you're really looking for sort of the greatest opportunity or the low-hanging fruit in the residential retrofit sector, you could sort of characterize your housing stock, and then you could use that to target the homes that had the cheapest and greatest energy savings. So it would sort of allow you to target different sections of the housing population that would achieve the greatest result.
Yeah, absolutely. I guess to the other panelists, did either of you think about it in that way, as how this could be used by a utility program manager?
For New Jersey, the reason that the thing that I was thinking about is that, at least for the Home Performance with Energy Star program, there's a sort of bias brought to the work done by the specialty of the contractor that's participating. And so I think it would be helpful for some guidance that would show that maybe some measures shouldn't be overlooked so quickly in order to go to others. So that's what I think could be helpful for, at least for the New Jersey Home Performance Program from the research that we did.
Okay, great. And Janet? Did we lose Janet? Okay.
I think I unmuted myself now. Are you there?
There you go. Yep.
Okay, sorry. We have a companion study to this program that includes occupied homes, and we're conducting that in conjunction with a Florida Power and Light grant. I think the most logical step from our field study and this associated study is looking at a package of what we would call a shallow retrofit that's going to be very low risk improvements. And by that I mean they aren't improvements that aren't going to impact the airflow and moisture flow dynamics of the house, because that's where you could get into real trouble with a prescriptive package, which I think necessarily at this point a utility program is going to expect to be prescriptive just because of the regulations that govern how those programs are set up. So the other companion study is looking at a shallow retrofit strategy in 60 homes to document both annual energy savings and peak demand reduction. So I think that's the logical thing, is to, from our research, is to cull through there and find the shallow retrofit items, those low cost, no cost items, and go with that as a first step toward a whole house program.
Okay, great. We have another question that is related to sort of a follow-up on the brick question previously, but just kind of for everyone. If you did run into masonry homes, did you have any suggestions for or opportunities for wall insulation methods? I know that we actually have some guidance on this on our website, and it was produced by a team that's not in this webinar, but if you just Google Building America and then masonry, then it'll pop up, and it's essentially a guideline for how to insulate masonry walls. So that might help with the attendees here. Okay. So we actually have some questions for the audience that we need to ask before we go. So we don't have any time for more specific questions for the presenters, but we will try to email everyone whose question we did not get to. So Heather, if you could put up the poll that we have, that would be great. Okay. And I just wanted to, while we're doing this, thank the panelists again. I mean, I think you guys did a really great job at explaining some of your projects. And if anyone who's on the webinar would like more information about any of these projects, you can contact the panelists or me. So you can see the first question there. I guess Heather got, okay. And the second question is if you thought the webinar's presenters were effective. You can just choose one. All right. And the next question is, overall, the webinar met my expectations. All right, great. So thank you all for joining us today. On behalf of the Building America program, I just wanted to thank everyone for joining us, including the panelists and the organizers, Heather, who's in the background. We really had a great audience. Thank you guys for being so interactive with your questions. We appreciate your time. And please check back at the Building America website over the next few weeks if you'd like to view the slides. It'll also have the audio there, so you can listen to the recording again if you missed something. And also just keep an eye out for the next couple of webinars that we have in our series, and they'll be coming up in the next month or so. So thank you all, and I hope you have a great day.